Hi. Hi, everyone. Very nice to see everyone here. So today we have a very distinguished talk by a visitor, Professor Fredrik Heintz. I suppose I spoke that correctly. He's coming from Sweden. He's actually a professor of computer science at Linköping, which I suppose is not so bad, where he leads the Division of Artificial Intelligence and Integrated Computer Systems. He has a very long bio, which was sent to everyone, so I will not repeat everything, but he's being a director of many programs and many projects. He's here to talk about Trustworthy Generative AI, a very important key topic today. So I'll ask Fredrik to take the floor. Thank you.
Thank you very much. So it's a great honor and pleasure to be here. So I'm really looking forward to presenting some of the work that we have been doing. And of course, I'm more than happy to have any interactions you wish afterwards. I will also start the presentation, just to give a little bit of background to what the activities that we do, both at Linköping University, but also a little bit about what's going on in Sweden. So if we can have the presentation, please. Yeah, and I forgot to change the title. I apologize about that. But basically, the content is the same. So it's all about how can we make this generative AI more trustworthy, but with a focus more on language models, because that's what I'm mainly been working on for now. So just to give a bit of background, so actually I've been working quite a lot with autonomous systems. So we had fully autonomous helicopters about 20 years ago. So there I was responsible for what we were calling bridging the sense reasoning gap. So basically collecting sensor data from cameras and other types of sensors, and then building up more symbolic representations of this so that we could do high-level reasoning. And we did all of this in real time on board our helicopters. So actually these were the kind of helicopters we have. So it's about 4 meters in diameter, 100-kilo platforms. I've also been part of RoboCup, so doing this kind of humanoid robots. We also built our own quadrotors. So actually we built our own quadrotor system, I think 2007 or something like that. We built first quadrotors. Before that we were using this double coaxial counter-rotating UAVs. So, and we actually had this cage. So actually I think we were the first to have this kind of protection cage around UAVs. So we basically could push this around. So I think we won a design award for that in 2004. Yeah, so we did a lot of work on drones and unmanned aerial vehicles a long time ago. So when I was a PhD student, we now also have a public safety arena where we're integrating different types of drones, but also spot robot dogs and many autonomous boats. So basically a wide variety of different physical platforms, all for supporting public safety. So different types of rescue missions, both air, land, and sea. So we have a very nice arena for that. So this is one part of my kind of background, but my main focus is really on AI. So I've been doing, actually I kind of started more in knowledge representation, doing a lot of ontology related activities. So we're using these ontologies to match the data that we have with the data that we want, and actually setting up computations to produce the data that we wanted, and we could represent this using ontologies. We were also doing what's called stream reasoning, so basically doing incremental evaluation of temporal logical formulas over streaming data, and we did that for runtime verifications, verifying that the systems were actually executing as expected. But please, I mean, sorry, I was waiting for someone to change the slides. Anyway, sorry about that. So actually, as I said, we have been doing AI for quite some time. So actually, AI at our university started in the early 70s with Erik Sandoval, who became the first professor of computer science in Sweden, and was also the first person to do AI research in Sweden. So he was over in the US in the late 60s, studying with John McCarthy and Marvin Minsky and these. Because his PhD advisor felt I cannot really help him, so I sent him to the US, and hopefully he can pick something up there. And then he got his PhD, and then became the first professor in computer science. So he really brought AI and computer science to Sweden. So it means that we have been doing AI research for more than 50 years. Actually, our university turns 50 this year, So we've been doing it all since the start. And this has had a number of interesting consequences, mostly that AI has not really been something of its own. It's only been always been part of computer science. So we don't have like professors in AI, but we have professors in computer science, and they do AI research. But it's clearly been an important part of our computer science studies for a long time. And today we actually have a quite good AI innovation, competence and research ecosystem in Sweden. So basically we have one program called the WASP program, the Wallenberg AI Autonomous Systems and Software Program, which is Sweden's largest research program ever. We have a funding of about 600 million US dollars over 15 years. And we started in 2015. So we're going to continue until at least 2031. So it's really long-term and also large-scale research funding. And this is for basic research, but basic research that will then help Swedish industry to be competitive in the future. So it's really about doing the basic research now in order for industry to be competitive in the future. And one of the goals is to educate at least 600 PhDs in the areas of AI, autonomous systems and software. So far I think we have graduated about 160 PhDs. So we still have more than 450 to go. Actually I think we probably will reach more like 700, maybe even 800 PhDs before the end of the project. Because now I think we have 450 or so, all right, probably closer to 500 that are in the program. So basically we are educating one PhD per week in the next like 10 years. On average, at least one PhD per week in the next 10 years. So it's really a large volumes. We're also doing establishing new research groups. So we are recruiting 80 research groups internationally to establish themselves in Sweden. And I think we have about 60 of those have been established so far. So it's really large scale and focus on basic research. We also have two kind of sister programs, one on humanities and society, so basically studying the effects of AI and autonomous systems. So this is more like humanities, social sciences, law, economy, and these kind of subjects, and then again studying the impacts of AI. We also have another sister program called WASP-ED for educational development, where we're then looking at how should higher education adapt to the need to more rapidly produce high volumes of competent AI people, but also how does this impact higher education. And there I think one of the key things is really how do we introduce appropriate AI content on all the other study programs. So today it's mostly in the technical areas, I mean the engineers and the computer scientists, and so of course they get this kind of knowledge. But what do the lawyers need? What do the medical doctors need? What do the HR specialists need? What do the economists need? And so on and so forth. So actually, Linköping University has said that we are going to introduce AI on all our education programs. And I think actually the rector has even said it should be by 2026. We only have a year before we should have started doing that. So this is quite interesting, I think, how we can define the appropriate knowledge that these other areas need. Because of course it's not about learning the technology behind it, but really how this impacts. We also have a program on AI competence, so this is more professional development. So providing professional development for companies and other organizations. So actually this was a program that was run a number of years back, but now we got some new funding for this year from the government to continue this. We also have this course Elements of AI, so it's developed by University of Helsinki with the goal of educating 1% of the Finnish population in the foundations of AI. They managed to do that in about a year. So then they set a new target. We want to educate 1% of the world's population in AI. And let's start with Sweden. So actually we translated this course into Swedish in 2019, I think it was. And then been running this also in Sweden for the last 5 years. So we have about 80,000-90,000 people in Sweden who has kind of taken part in the online course. And you can also get university credits from this course. Actually, we have close to 11,000 people that have received university credits from this course. And of course, we have automated most things. So I run that course with basically one teaching assistant, and we can then manage to examine about 1,000 students every semester. So that's very nice. We also have AI Sweden, which is then working more on innovation and accelerating the use of AI in both public and private sectors. So it's really about spreading and getting the uptake of this technology. It was called AI Innovation in Sweden from the beginning. And then I have been coordinating two large EU projects. So TAILOR was the European Union network of research excellence on Trustworthy AI. We're really focusing on developing the scientific foundations for Trustworthy AI, and that we did this through the integration of learning, optimization, and reasoning. That project is now ended, so it ended last year. And today I lead TrustLLM, which is then another EU project on developing trustworthy factual large language models, which I will be talking more about later. And here, so this kind of gives an idea of some of the ecosystem in Sweden. And of course, Linköping University is one of the key players. So we are the host of this VASP program. We're the host of this VASP ED program. So actually, I'm the director there. In the VASP program, I have been responsible for building up the graduate school. Now I'm a co-director responsible for international collaboration. So I'm one of the co-directors there. AI competence, we have also been involved in this also. And of course, there's also much more going on the European level, but I will skip that. So I think one of the things that Linköping University is known for this is that we have been running many of these large national research initiatives. So really being able to both practically dealing it, but also earning the trust of the different funding agencies to do this. Actually, we have, for example, a large initiative in material science for sustainability. So this is like $300 million US, also I think over 10 years or so, that we are also hosting. We also host all the national academic infrastructure for supercomputing. So we have been running HPCs for quite some time. And then we got a special donation from the Wallenberg Foundation to build an NVIDIA SuperPod. So we have an NVIDIA SuperPod, I think it's 800 A100, so it's kind of old now, but now it's being upgraded with H200s. We also got one of the Euro HPCs, so one of the European networks of high-performance computing is going to be built in Linköping, and we also got one of these, what's called an AI factory. So this has been the EU concept for how do we make HPC computing more accessible, more available to small and medium companies and different types of organizations. So it's very much about how do we simplify access, how do we provide services and support for making this computing infrastructure available. So we are one of the 7 of these AI factories in Europe. So we're really kind of combining this large-scale computing with technical competence in AI and other fields, but also with the competence of really managing these large projects and initiatives. I think another thing that sets us apart is that we really covered the whole breadth of the AI area. So we have in most of these different sub-disciplines of AI, we have one or sometimes even several research groups working on it. So for example, computer vision has been one of these areas we've been working for since the 70s, I think. And there we have like 3 very well-known research groups, one in more kind of the hardcore computer vision, but then we also have medical visualization and also more computer graphics and visualization in general. So really broad area. Machine learning. So I lead the AI division of AI at the computer science department. We also have a division on statistics and machine learning, as we even have 2 different divisions within the department working on this. So we really cover this broad spectrum of things. So if we then look at the division that I lead, AI and integrated computer systems. So people ask, why do you call it integrated computer system? And then this was really because we started out integrating AI into autonomous systems. So really about integrating it into physical artifacts. So that has really been one of the starts. So actually, Patrick Doherty was the one that started this division, I think about 25 years ago, and I took over a few years back. And we have a number of different labs within the division. So we have Patrick's AI labs, which is going to do most of this UAV stuff, so that's where that's taking place. We have a machine reasoning group led by Jendrik Seid. We have an NLP group led by Marco Kuhlmann. We have my reasoning and learning lab, and we also have more theoretical computer science lab, basically studying the theoretical foundations, complexity theory, and so on, often related to AI related problems. So in total, we have about 50 to 60 people in the division, about 25 or so faculty, and 25 to 35 PhD students and others. So it's kind of reasonably sized group that we have. And one of the things that I've been doing the last couple of years is that I've been working on building up collaborations between Sweden and Brazil. So I think the starting point is really the sale of the Gripen fighter to Brazil a number of years back. And then as part of this agreement, it was about knowledge transfer and tech transfer between Sweden and Brazil. So that has been going on in aeronautics for 10, 15 years. And then 4 or 5 years ago, they wanted to broaden this to also include AI. And then I was approached if I wanted to kind of be this Sweden-Brazil professor chair of AI and autonomy. And I've been doing that since 2022, I think it is. November 7th, 2022. So I've been doing this for a number of years, and basically it's about starting up different types of collaborations. And I've mostly been in the kind of Sao Paulo region, but I also have collaborations with Fluminense in Niterói, that I'm going to later today, and a number of other places. So it's not kind of focused on one particular location, but more about finding different ways of collaborating. And one of the things we have been doing there is that we have hosted Brazilian researchers, so both PhD students and postdocs, and there are special grants that you can apply for to send students to Sweden for part of the time. So I think that's a very nice way of building collaboration. And of course, I come here regularly and is happy to meet, interact, and find interesting things we can do together. So this was kind of my introduction to more kind of why am I here, what are some things we are doing. Now I kind of go into the more content of the particular presentation, namely this towards trustworthy generative AI. And of course, I mean, we all know that AI development is very rapidly. There's a lot of things happening. We have seen the last 10, 15 years how we have gotten these kind of applications of self-driving cars and superhuman performance in games like chess and Go and poker and StarCraft and Dota and Bridge and so on and so forth. Just whatever game you can come up with, it's just a matter of time before the machine is better than we are. And now, of course, the focus is on generative AI. And you can start to kind of compare how are these systems doing against humans, and in different particular areas. One can argue that these systems are reaching at least the level of average humans in many of these tasks. And as I said, I think today the focus is very much on generative AI. That's what most people find interesting. And I usually say that the kind of major breakthrough, or when the generative AI became more widely known, when people started to pick it up, I think was when OpenAI released DALL-E 2 in April 2022, so about 3 years ago. What you could do then was that you can take these short prompts, and then you can generate photorealistic images that we find exciting, interesting, and stimulating. And from my point of view, more kind of a computer science perspective, is that I find that what's interesting here is that you have very limited information. So I mean, in this prompt, there's very little information, but in order to generate an image, you have to fill in so much detail, so many specifics, and that's quite fascinating that you can do this in a reasonably good way. So for example, in this case, it says teddy bears. It doesn't say how many, just that it should be plural. But then you have to choose, should be 2, 3, 5, 10, 100, 1,000, and then it chose 2. It's like sparkling. Well, I guess there are some sparkling stuff in the middle there. Chemicals, I don't know what about the chemicals, maybe that's what's sparkling, or it's the test tubes, and so on and so forth. So for each of these things, you have to create something that's actually reasonable, which they managed to do. Of course, this was DALL-E 2, so there's been earlier versions around, but this is what kind of got people interested. But it's not only, let me see, oh well, I guess that's unfortunate. There's also video. So this is the videos from Sora. It's kind of pointless now because it's not a video, so now it only became an image. But anyway, you can then use the same kind of prompts that you use to describe an image to then describe how you want this scene to look like. Basically, what are the different shots? I mean, in this case, you're describing the person in the scene, the kind of environment, signage, neon light, what kind of clothes she's wearing, and so on and so forth. And if we actually could see the video, we would see that she would be moving around in this Tokyo-like landscape. You could see the reflections in the wet surface, you could see the reflections in the sunglasses and so on. So really these kind of things that we considered, or that's kind of difficult to do well. So it really shows that you can actually generate this on-demand video content from short descriptions. And I actually think this kind of on-demand video generation can be extremely useful, because basically previously you had to think of what do people want to see, then you have to kind of design and define and actually record the material. Now you can just generate whatever purpose, specific purpose content you want. And of course you can imagine, for example, educational settings that a student has a question about something, you can just generate some information about whatever the student is asking for, or generating instruction videos for how to carry out things and so on. So I think this kind of on-demand video generation is going to be extremely useful. You can also use it to generate sound and music. So there are services where you can basically ask for a certain type of music and it will generate that music for you. But I wanted to come back to this with text, because even though I think these images and videos and so on is of course very nice and useful, I think the more especially useful things is working with text. And why is this important? I think one of the reasons is that basically everything in our society, in our culture, is very much text-based. And it's based on natural language. And by having these models which now can process, analyze, interpret, generate this kind of natural language text, it basically makes most things in society available and accessible to this kind of tools. So I really think this will have a major impact. But I also think the number of applications, the number of things you can do with these kind of language models is basically infinite. And we haven't even started to scratch the surface of what can be done with these kind of systems. But we can definitely see this kind of writing text, generating text. That's number one application people see. But what we see maybe from a more educational point of view is that actually what's much more relevant is to use it to get rapid feedback so that you can improve your own writing. You can get feedback on how should what are the counter arguments to my argumentation, or how can I improve this line of thinking, or what would a different type of audience like to see this, and adapting the content and getting feedback and improving it. I think there's so much to do in this kind of interactive writing of texts that we have just started to see. I also think programming is very interesting because, of course, computer programs is just another form of text, which means that you can use these kind of programs to generate computer code, but you can also use it to get help with debugging and finding problems with your code. People are starting to use it to do security audits, so automatically audit large amounts of code to find security vulnerabilities and so on. So all kinds of things that you can do with these computer programs. And I think this is probably one of those areas where most where it's actually kind of professionally used the most today, where many professional software developers are using this on a daily basis to improve their work. But actually, it's not only humans that can improve and take advantage of this with this on-demand computer program generation. Actually, the language models themselves can do this. So one of the things that these language models are terrible at is math. They cannot do math. So previously, if you asked it, for example, to what is the multiplication of two large numbers, it would just make something up, because it has no clue. Just make something up. What it does today is that it realizes that you're asking for a math question. It then generates a Python program to compute the answer to your math problem, and then it executes the Python program and gives you the answer. So it's using computer programs to help solve the tasks you give it. And now you have a language model which is actually generating on-demand, custom-made programs in response to the kind of queries it gets in order to help it solve this. And I actually think that's quite interesting. And you can also use it not only to do math problems, but if you want interactive user interfaces, then it can generate like JavaScript code or whatever, and then you just can run it in your browser, and you actually get an interactive visualization that you can use to interact with the answer to your problem. So I think there's quite a lot of power in this, being able to generate computer code and then kind of executing it within the language model, and that really widens the scope of the things that these language models can do. So that's quite interesting. Of course, information retrieval is another one of these major areas, and we see now that people are replacing their search engines with using language models. So instead of getting a set of links, you basically get the answer to your question directly. And of course, many people are starting to think that will this be the end of Google, that their kind of business model of selling ads in relation to search, whether that will hold up for this or not. And we are of course seeing that they also provide this kind of summary. So when you search for something, you should get a summary, and then you get the links in some sense to try to prevent this. But we're also starting to see these kind of more special purpose language models based search engines like Perplexity. OpenAI is also starting up search, so you can search using their systems. So I think this will also be interesting to see how this continues. But I think in some sense more importantly, and in some sense of course related to that, is this more document summarization, or being able to interact with large volumes of documents. So instead of having to read and search for the information yourself, you basically can ask the question, so please find all the places in these documents where they contradict each other, or find all the places in these documents where they talk about this, and summarize that. And so you can basically get a more flexible interface to large collections of information. So I really think this is probably one of the key ways interacting with large collections of documents. Instead of reading them, you have a conversation around them, and then you can ask for different types of summaries and so on. But I mean, the number of applications is, as I said, basically infinite. So these are just some small examples. And now, of course, we are seeing not only the Americans, but also the Chinese producing this, for example, DeepSeek. But the reason I included this here was more to take it as an example of this reasoning models. So not only just generating the most probable next token, but actually starting to have a bit more sophisticated reasoning on top of it. Even though I guess we can discuss that, whether that's the case or not, but at least not trying to do a bit of a search over the possible continuations and then choosing the best, or doing an aggregation of that. And I guess probably this will not work either. Yeah, this was another video, but you have OpenAI has also released this deep research. So basically, you can now use this to generate research reports. So I think the prompt here was to generate an overview of how the retail industry has developed the last 3 years, use bullet points and graphs as applicable, and then the system will come back and ask for clarification questions, so that it kind of narrows down what you're asking for, and then it will go out, search for different sources of relevant information, and then start aggregating these different sources, and then generating a report according to the specification you gave it, including bullets and figures and graphs and whatever you ask for. And I think this is then just the next step, where we're starting to see more complex use cases, but that is using this kind of language model as the engine to achieve these relatively sophisticated tasks. Yes, we can also start to discuss, what is the relation to AIs? All of these have been examples of kind of AI applications. I would argue that we're still working in this more artificial narrow intelligence area, where we basically have systems that are at least as good as humans on one or a few things. We, of course, are starting to approach something that's close to this artificial general intelligence, where you have then AI systems that are as good as people are on all tasks. So basically it's about adding this generality and not only being good at a few things, but actually having a broader capability of being good at many things. And basically you want to kind of reach this kind of human level intelligence. Some people, of course, argue that these language models are basically already doing this. Personally, I'm not sure I would equate next token prediction with human level intelligence, but it's definitely a very broad and useful thing. So, and here my personal view is that I don't think there are any kind of technical reasons why we shouldn't be able to reach this level of kind of human level intelligence. How long and when, I think, will be very much up to debate on when we agree upon we have reached it or not. But I think, and I also think that maybe the implications are not that huge on society and so on. But I think the interesting case is, of course, when we reach the more artificial superintelligence, where we then have AI system which then vastly outperforms people on everything. And then I think there becomes a very different story, and the effect could be much more significant. But there it's not clear to me that it's even technically possible, and I'm not particularly worried about that for now at least. We can also see that I expect the impact on society to be quite significant, in the sense that I think it will transform a lot of things that we do in society. And one of the studies that I used to argue for this is the study that was released about a year and a half ago, where they had studied 700-800 consultants at Boston consulting groups in the US over a wide variety of different types of tasks, and came to the conclusion that those consultants that were using these AI tools managed to solve more tasks in this, 12% more tasks in the same time. Each task took on average 25% shorter time, and it could also increase the average quality that they completed this with 40%. So basically got more, better, and faster by using these kind of AI tools. And I think there are very few companies or organizations that do not like to see these kind of benefits. So I definitely think this will have a major impact on work. Another positive aspect of this study was that those that had the most benefit from these AI tools were actually the junior consultants. That they were able to carry out tasks that previously had required more experience, more knowledge than a junior consultant would have. So basically you were lifting the lowest part of the company. You were not really kind of throwing out. You could imagine that if you're not better than what these tools are, then you have a very hard time contributing anything. But that was not the case. The case was rather the opposite, that the young ones, the less experienced ones, were the ones that had the most advantage, because they could be complemented by these tools and do things that they otherwise could not have done. And actually I think we could very well see a kind of a strange effect here, namely that those that are experts on their fields will still be significantly better than these tools, while those that are not experts actually are the ones that benefit from it, because they can now at least partially carry out these things. And I think you might get an interesting effect if you have an organization and now you want to evaluate, should we use these tools in our organization or not? And then probably you will ask the most senior people in your organization, can you please evaluate these tools, and can you see if you find any value in them? And from their point of view, maybe it doesn't add much value. because they're already so good at what they're doing that these tools don't make much difference. So in some sense, maybe they should ask the least experienced people and see, can you now do things that you otherwise would not be able to do? Or you take the experts and now ask the experts to do something else that they're not necessarily very good at, but in a different area. Then I think you will get very different results. So I think we will see interesting aspects here as well. But it's definitely the case that I think it will have a major impact on both work and education and other aspects of society. And that's why I think, for example, the EU approach is very positive. I mean, that we have said in the EU that yes, we want AI, but we don't want any AI. We want AI that we say is human-centered and trustworthy. And with this, we mean that, with the human-centered part, we mean that it's not AI in itself has no value. It's more what benefits does the technology create for us as individuals or as for society. That is the important part. That is what we should focus on, the value creation part for us humans. And the trustworthy part, we actually had a high-level expert group, which I was part of, where we then defined what we meant with this trustworthy. So we developed these ethical guidelines for Trustworthy AI. They were released in 2019. And there we defined that in order to be trustworthy, you basically have to satisfy three parts. You have to live up to the applicable rules and regulations. You have to be lawful. You have to satisfy 4 ethical principles that we put forward as fourth. And then you have to have a robust and safe implementation. So it's not enough to have good intentions. You actually have to build a good implementation as well. And if you satisfy all these 3, then you can argue that you're trustworthy. Of course, it's easy to state these things. I mean, there are many organizations that are stating similar things since then. So actually, we did a number of steps. So we defined the principles. We also defined requirements that were then closer to something you could implement. And we also defined an assessment list, so basically questions you can ask yourself, are we achieving this kind of criteria or not? So we really tried to take it a few steps forward, but this was just a 2-year project, so we couldn't do too much. But the principles that we put forth was that you should respect human autonomy, meaning that these systems should augment, complement, and empower people rather than compete with them. They should also prevent harm, both physical and mental harm should be prevented. They should be fair in a broad sense, so there should be some rough equal distribution of both the benefits and the costs associated with these tools, so that it actually benefits the many. And finally, it should be explicable, meaning that you have some understandability in a broader sense. And here things included like transparency. You should be able to understand if you're talking with an AI system or not, and having an understanding of what the capabilities are, so that you can determine whether the answers you get are reasonable, or you can expect them to be reasonable or not. So these were the principles that we put forth. Then after that, what has happened is that the EU Commission has then continued the work and then developed a legal framework. So now we have something called the AI Act, which is then a law regulating AI that came to effect in August last year. And in the AI Act, we take a risk-based approach. So basically, if you want to put an AI system on the market, you need to estimate the risk associated with this particular application. And depending on the level of risk associated with the application, there are different levels of regulation that applies to this. What's interesting is that there are even a category of unacceptable risks, so that if your application ends up there, it's actually prohibited. And here examples include social scoring, subliminal manipulation, untargeted scraping, but also remote biometrical identification, so basically identifying individuals in real time in public places should not be allowed. But then I think that the kind of interesting category is actually the high risk. So this is the category where there is a kind of significant impact on the individual's, say, health or economy or so on. And there is kind of more significant ex-ante regulation that you need to satisfy. So basically, before you put the product on the market, you have to live up to this regulation. But then the expectation is actually that the vast majority of AI applications should have very limited risks. So basically, there's no further regulation. So for example, take this with chatbots and so on, there's basically, you should be transparent about it. You should know that you're talking with a chatbot and not with a person. So not much extra regulation. And if you have more industrial applications, there should be basically no further regulation. So we will see, I mean, this is now being gradually introduced. So the law came to effect in August last year, but it's like a 3-year period where more and more of this regulation then becomes in effect. So actually this unacceptable risk is now in effect since the beginning of February. So that was the first thing that came to effect. The second thing that would come in effect is that now in August is that all the member states have to appoint expert authorities to help implement this regulation. So we will see a lot more developments here, I think. So now, and I talked about a little bit about the kind of technology itself, but also about the impact and also the regulation. Now, of course, it's very interesting to start thinking about is this kind of generative AI that we have, is it really trustworthy? And my intention here is to give a few examples. Actually, this was an example I generated a little bit more than a year ago now, and I just needed an image of a self-driving car for a presentation. So nothing strange with that. I just, well, used DALL-E. So actually we have made Microsoft Copilot available to everyone employed and all the students at the Linköping University. So everyone at the university has access to these tools. So I just used Copilot to generate this image. And then I've been using it for a while, and at some point in time I just started to look at the right-hand side of the image, and then I started to think, which side of the road is this car actually driving on? It's very unclear. It looks like it's driving on the left-hand side of the road, because I mean there's a bunch of lanes over there. And then, I mean, it kind of looks like an Alp landscape or something. And as far as I know, there are no countries in that kind of landscape where we have left-hand driving. And then, so actually, maybe it's actually driving against the traffic. We don't know. I mean, it's hard to know. And then, so that's one thing. It's also kind of funny. It looks like it has some exhaust fumes there, but I mean, it must be an electric car. So it's also very strange. You can start to look at the door. Is it one door, or yeah, how would that work? So I mean, the point here is that usually you only focus on the foreground, and then things looks perfectly fine. But as soon as you start to look into the more details and the kind of specifics, you usually find all of these kinds of strange things. And now it's very unfortunate that I cannot show the video because the whole point of me showing the video twice is that the first time you look at it, you will probably don't notice all the strange things that's going on. But now I guess I just have to tell you all the strange things that will be going on in this video. And I would have then told you to look at the feet of this woman. So first of all, her legs looked a bit wobbly, almost like they're plastic. But that's not the point. The point is that at some point they basically shift positions of the left leg and the right leg. But the shoes are still in the right position, so I think that's very convenient. You just switch the position of the legs, but the shoes are still correct. She will do a little bit of just jumping steps instead of walking, and all kind of strange. And then the legs will change back, so maybe then they're back in the original position. So there's clearly something that apparently is not a solved problem, how to get the feet to be dealt correctly with. You can also see here that she has a purse in her hand, and you will see that she carries the purse, and then they will zoom in on her, and then when they zoom out again, the purse is gone. So she just stand there having her hand in her pocket, and there is no purse. Of course, maybe she has kind of big pockets, so maybe it can fit the purse there, but more likely it just disappeared in the process. So actually getting this kind of temporal consistency is difficult. And I mean, basically the reason is that it just looks at a short sequence of time back. And then if it's too long ago since there was kind of seen the bag, it doesn't know that she had a bag earlier. So therefore it kind of loses track of this temporally relevant information. And of course, this is the same thing with these large language models. They also make all kinds of mistakes. And I mean, they do this kind of hallucination and so on. So actually, when it comes to hallucination, I actually don't think the hallucination itself is the problem. The problem is that we can, of course, very well accept when people make things up. And in many cases, we want them to be made up. If we want to generate a story, if we want to generate a joke or something like that, then the whole point is that it should be not necessarily correct. But if you're asking for, say, medical advice, not that I would recommend anyone to ask for medical advice from these systems, but then of course you don't want it to make things up. And I think the core of the problem here is that these language models have absolutely no understanding of how well it knows anything. So there's no notion of uncertainty. It doesn't know that, oh, this is an area that I'm good at, this is an area that I'm bad at, or anything like that. It's just, it's kind of, yeah, it's as good as it will be on all these areas. And therefore, I think it's very difficult to kind of address that with the current methods. So there are a number of these issues. So why do we have it like this? So just to briefly describe how these systems actually work. So I mean, if you take these kind of ChatGPT systems, actually I would say they contain 3 different components. So the first component is this GPT model, the generative pre-trained transformer. So this is the kind of the system that's been around for a long time. So I think GPT-3 came in 2020, and I think the first GPT model maybe was a few years before that. So these models is basically, they're generative, meaning in this case it means that it's a probability distribution. So they've learned a probability distribution over sequences of words, or we say tokens, because you transform the words into numbers, and these numbers are called tokens. So you have this sequence of tokens, and then you learn the probability distribution of, given this sequence of tokens, what is the probability distribution of the next token in this sequence. And then you can sample from this probability distribution to generate new content. So that's the generative part that you can sample from these probability distributions. The pre-trained, meaning that it's trained on a large amount of generic text. And they don't even need to have any understanding of what the text is about, because the way that you train it is basically you take away parts of the text and then you learn to fill in the things that you took away. So it basically can learn to fill in the blanks, and thereby it doesn't need to know what the text is about, or doesn't have to be the same language. You just throw in anything you like, and it can learn from that. And that's why it's also called autoregressive models, because they're basically learning in a self-supervised manner. So what you will get here is basically a statistical model of how these texts that you have trained it on works. So I mean, the probability of the next token in those texts. And as I said, that's been around for quite some time, and of course you can do quite a few things with them, but they didn't get the big acceptance that ChatGPT got. So what was then the difference between GPT and ChatGPT? Well, it's because that we did this kind of fine-tuning. So basically, instead of having a generic model of how the language works, it was more to make it more tailored towards how people want to use it. So here there are a number of ways to do fine-tuning. For example, instruction fine-tuning, where you basically have particular types of instructions or things you want the systems to do, and then you adapt the model to generate those kind of instructions. But you also have this reinforcement learning from human feedback, where you have let users tell whether it's a good or a bad answer to the different questions it asked. And then you try to adapt the model to be more of the things that users want and less of the things that users don't want. So you're adapting it to the particular user's expectations and so on. And this was then what that was released in November 2022. So actually GPT 3.5 was released in the spring, no one cared that much, and then they released ChatGPT in November, and then everyone cared. And then since that, we have also added this extra layer called retriever augmented generation. So basically this does not change the model, it only changes the prompt that goes into the model. So that instead of just taking the prompt and directly feeding it into the language model, what's now done is that you look up relevant context and relevant background information, and then you extend the prompt with this extra information, and then you send this extended prompt into the language model, and then you get a much more accurate and much better response back from it. But it doesn't change the model, it only changes the input to the model. So this was then added the year after. And then what has happened the last year is this adding, since 01, adding some form of search kind of like method on top of the language model. So instead of just taking the most likely next token, what it does now is, for example, this chain of thought, where basically the system has an internal monologue regarding the topic, basically generating multiple different types of answers to the same question, and then it uses the language model, for example, to summarize this kind of different ways of thinking about it, and then producing this summarized result as the answer as one way. There are other ways as well. So the whole point here is that not only explore one particular continuation, but actually exploring multiple different continuations or different ways of answering, and then aggregating this in some way to get a better end result. And now, of course, we see this also with O3, which is done better, and then DeepSeek, which is also doing this. And actually, Open AI do not reveal their more this internal chain of thoughts process. But of course, if you use DeepSeek, they would gladly just spit out everything that it's thinking about, and it of course does it in several different languages, so it might start to think in Chinese in the middle of the argumentation and so on and so forth, but just be much more kind of open with how these processes actually work. So this is the kind of latest development there. So we can also see now that we're kind of shifting the scaling. So we started out kind of just building larger and larger and larger models. So basically this pre-training scaling. We then did more and more post-training, so this kind of fine-tuning, alignment, reinforcement learning, and all these kind of things. The post-training scaling. And now we actually do test time scaling, basically investing compute time for each particular question or each particular query, and then you can see how much compute are you willing to spend in order to improve the answer to these questions. So we can see a kind of a development there as well. Oh, excuse me. Yeah, so I think in conclusion, I would argue you cannot trust ChatGPT, but it doesn't, just because you cannot trust it, it doesn't mean that it's not useful. So I think if you're using it in a critical manner, and if you kind of verify the results, I think it can be extremely useful. And of course, if it's a use case where it doesn't matter if it's completely right or not, then it's a different story. But definitely useful, but definitely also not fully trustworthy. Which then leads me into this project, the TrustLLM project, where we then want to, how can we build language models which are both more trustworthy, but also more factual, so they actually become more correct. And we have been gathering organizations which have extensive experience in actually training and building this kind of large language models. So we have AI Sweden in Sweden, who has been developing GPT Suite, which is a Swedish model. We have Fraunhofer in Germany, who has been running a large German project called OpenGPTX and making German models. We have TNO in the Netherlands, responsible for the Dutch language model. We have Mid-Ind and University of Iceland who actually been cooperating with OpenAI and trying to get the OpenAI language models to deal with Icelandic. But apparently Icelandic is challenging because the tokenization that works well for English does not work well for Icelandic. So you need many more tokens for Icelandic. And since the quality is proportional to the number of tokens, it means that the quality in Icelandic is actually much worse. So we have people who have this kind of experience, and now we want to look at this from the point of view, basically from data collection to pre-training to fine-tuning to evaluation and integration in applications. And we started about a year ago. And we focus on reliability, fairness, and a little bit on explainability and reasoning. And we are working on this factual correctness. We also want to deal with modular and transferable multilingual training. So, I mean, one challenge is that you have small resource languages with not very much data. And, of course, training our own models. We also is very much working on how can we establish the ecosystem around LLMs and working with benchmarking and data management. So we also want to kind of combine, so I mean, it's mainly a research project, but we also want to train models, both to kind of verify the research that we've been doing, but also in order to have something to evaluate and that we can improve. So basically the intention is to release a model every year or to produce a model every year. So far we have created a baseline model that we can use as a reference when we go forward. So we have something to compare against. We are now working on fine-tuning it and benchmarking it to see how well it goes so far. So we have done a number of things already. So data set and first versions, but we definitely want to iterate and improve over time. So this is not something we're just done with. And I would say that actually the number one challenge for us has really been data. So I mean, we want to be compliant, so we want to do this data collection in accordance with regulation. And this has turned out to be much more difficult than, well, maybe could imagine. And I would say the number one challenge is that there is not a single interpretation of the regulation, meaning that you get very different answers depending on who you ask. So this has really been the challenge, and I would say that also within the consortium there are very different views on what is sufficient or what do you need to do to be compliant. So as I would say, this kind of legal uncertainty around compliance is the number one challenge. But one thing we're interested in is, can we basically set up filters that are connected to different types of regulations, and then try to kind of encapsulate the regulation in terms of filters, so that we can apply this to the data to, for example, filter out copyrighted information or filtering out personal identifiable information and so on. Because if we could then get that, these filters or these processes, they are sufficient to be compliant, then it would be much easier. And if it's not compliant, not sufficient to be compliant, then it is, okay, what do we need to change? What is it in this process that's not sufficient? And then you actually can iterate and improve over time. But then you talk to lawyers, and then things are never easy. Anyway, so we're working on this kind of data processing pipeline. As I alluded to shortly, I mean, before was also this, that the data, we have a large amount of data in English. There's a lot of code available. Actually, German is not too bad. Dutch at least shows up, and Swedish as well. But there are many languages which are very, very low resource languages. The most extreme case for us is Faroese. So it's like a small island in the vicinity of Iceland with like 30,000 people in total. And I mean, there's not that much language written text in that language. How do you deal with those languages? Because basically we know that if we want to have a kind of a best possible model, we should have like a uniform between the different languages. Because if you have very unequal amounts of data, for example, you have a huge amounts of English, it means that basically the first language of the model will be English. And actually this is something we have observed in models that we have evaluated, that even if you ask it, for example, to produce German text, it would gladly produce German text, but if you don't ask it to continue, at some point it will switch to English. So it can go back to its native language, and then it will continue in English. So even though you can kind of force them to generate other languages, it's clear that it has a preference. I mean, especially this American model have a preference towards English because that's what mostly they've been trained on. And of course, I guess the Chinese might have Chinese preferences. So this is one of the things we're working with. And here we're also looking into, so I've been working on synthetic data for a number of years. We have mostly been working in time series data, so basically doing generative time series models and then using this to generate synthetic time series, for example, of people movement in cities or things like that. And now the idea is basically, can we use the same kind of techniques that we use for synthetic data in other domains, also use it for language? So I think this is interesting. And one of the reasons this is also interesting is that in this process of first learning a generative model of sensitive data and then sampling this model to generate a new data set that's then less or non-sensitive, we can also deal with bias and representativity. So for example, in the training process, we can remove the statistical correlation to sensitive attributes. So we can remove them from the decision. In this sampling process, we can of course resample it to make sure that all the groups are equally represented. So there are a number of things we can do to improve the data in this process, which we also think is interesting. So this is something we're going to investigate. When it comes to this factual correctness, I think that the number one step is really to look at this retrieval augmented generation part and to make sure that you generate factual correct information that you can then identify in the prompt and then add the relevant information to this extended prompt using, for example, knowledge graphs and other techniques to do this. So that's one idea. We're also interested in how can we kind of integrate this in either the pre-training or more likely the fine-tuning part so that you can do this. There's also techniques on knowledge distillation, so distilling a smaller and more compact model, but still doing it in a way that you kind of maintain the things that you knew in the larger model and maybe even improve it. So there are a number of techniques we're investigating there as well. And when it comes to dynamic knowledge, we're interested in looking into how can we, because today basically there is no sense of time, these models have no sense of time, and the data usually is not temporal. How can you make the data more temporal, and how can you take this into consideration when you build this model? So that's also something we're looking into. We're also working with alignment. So basically when we talk about alignment, there are a number of different ways of doing this. We can do the alignment in the pre-training. So then it's basically about making sure that the data that you use and collect is kind of aligned with whatever values you want to have. You can do instruction fine-tuning, so basically having specific high quality data that's used to improve the model after your pre-training. And then we can do this kind of preference tuning, where you then have this user feedback and then adapting it to the particular users. Let's skip this. And there are a number of ways of getting alignment data. Of course, we can collect human-generated data, which is very nice, but we can also use synthetically generated data. But actually, research has shown that having a small amount of really high-quality alignment data is actually better than to have large amounts of low-quality data. So this has been our focus. Can we collect a relatively small data set, so 1,000 samples, for example, in the different languages that we are focusing on, which are the Germanic languages, and then using this, we're basically doing our own data collection effort on high-quality alignment data, and the intention is then to release it and make it open for everyone to use. We're also working with evaluation. So you probably all have heard about this Move 37 in the AlphaGo games. But the point here is really that I think there will be a major challenge in actually evaluating how good these models really are. And this move 37 just shows it, because basically what you had was that the best human experts thought that this was a bad move, but objectively from the point of view of the game, it was a good move because the computer used the move to win the game. And then you have the situation where the best human expert thinks it's bad, and objectively it's good. And how do you kind of then use this human expert to evaluate these kind of systems? So I think that's going to be a challenge going forward. And when you do the kind of evaluation, there are a number of different ways you can do it. You can just, well, try it out and see whether it feels good or not. I guess everyone does that to some extent. You can kind of organize this a bit, so you have a group of people doing this evaluation, all using their gut feeling, and then aggregating that, then you get something better. You can also use language models to basically evaluate other models or the outputs. And then you can use benchmarks, which is then the more systematic approach to collect relevant questions and then checking the quality of the answers. And then you can systematically compare different models against each other. And we have then been working on our own evaluation framework called Scandeval. So basically we are developing this multilingual benchmarking framework, which then focus both on understanding and generation. We can evaluate both encoders and decoders, and this then allows us to have a broader variety of things we can evaluate. It's also robust in a more statistical sense, so we deal with some of the stochastic parts so that we can make it as deterministic as possible to then make the comparison more comparable. And multilingual, I mean, since we focus on the languages that we know, that we have kind of first-hand experience on, we focus on the Scandinavian languages, but it's extendable, so it's not limited to that, but that's just the languages that we kind of provide, and the kind of languages that we are interested in evaluating on. So yeah, we localize these different things. So what are the things we evaluate? We evaluate, for example, text classification, linguistic acceptability, extractive question answering, and named entity recognition. So these are then all examples of natural language understanding tasks. We're also working with some of the generation tasks, summarization, world knowledge, and common sense reasoning. So we cover quite a broad range of different things. And of course we have a leaderboard, and then you can see how different models do, for example, in these Scandinavian languages. I guess that's less relevant to you, but the point is more to be able to do this kind of comparison. And what's important, or I mean, one observation here is that it's actually different models are different good at different languages. So even though roughly the same models kind of show up in the top positions, the specifics vary between the different languages. So I'm sure that probably applies to Portuguese as well, or that's depending on what type of questions you want to ask, you get different models that are the best. So to summarize, we are basically covering the whole spectrum from data creation to pre-training to model alignment. We're also looking into model transfers, that's more the research part, and we really want to do this in an open and collaborative manner to be as inclusive as possible. Yeah, I have some more about other things, but yeah, I think I would just skip in the sense of time. But I really think the one thing that I think is interesting going forward is, of course, will it be sufficient to just have this kind of data-driven machine learning approaches? And I don't think so. I don't think we will be able to solve, make this model actually fully trustworthy and fully kind of compliant with regulation through just using machine learning. I think we need to also take advantage of and incorporate technique coming from more formal reasoning approaches, which where we have guarantees and we can actually prove properties and provide this kind of guarantees that you want from a legal point of view. And of course, I think what's interesting is now to look into this combination of how we can combine this data-driven machine learning method with a more knowledge-based reasoning type of methods. and Neurosymbolic AI is then the field that's trying to kind of encapsulate this, and it's now being shown up on the Gartner hype cycle as one of these innovation triggers, as one of the kind of potential technology that would lead to the next generation of AI models. And of course, I find that very interesting and very interesting going forward. So to conclude, I can just say something about the trends as I see them. So one question is that will large language models just continue to grow? My expectation here is that we will see basically two trends. One trend, yes, that the kind of most capable general models will probably continue to grow for a while at least, and they will be the most generally competent models. But I actually think when it comes to more specific domains or to different use cases, we will see much more smaller, more adapted, more focused, domain-dependent models, because you can both improve the quality within that particular domain, but also that you make them more cheap and more energy efficient to run. And of course, if you're going to run this for thousands or millions times every day, then cost actually becomes a matter, and you don't want these extremely large and inefficient models for things that you can do simpler. So basically, I think the question would be, what is the smallest model that still solves the problem? That is what you want to find. And we are also seeing a lot of trends towards multimodal models. I mean, so far it's basically unimodal models, but we definitely start to see multimodal models, especially between text and images. So asking questions about images and generating images and these kind of things. Reasoning models, I guess we can have a discussion whether they're truly reasoning models or not, but that's definitely a trend. We also see this, that if you want to use these models to not only kind of talk about text, but actually to want them to have some kind of meaning in the physical world, then we need probably something different, because now the models are grounded in text, they're not grounded in reality. And I think this is another one of these areas that we see a lot of interest in. How can we actually ground the AI models in the physical reality so that the output that they produce actually makes sense in the physical world? And we see a lot of interest in the combination of AI models and robotics, for example, towards this. Agentic AI, more having AI systems not only being more passive or reactive, but actually having proactive and active AI systems, collecting data, carrying out things on our behalves. And for those of us who's been kind of working in the agent field for a long time, it's kind of funny to see how old concepts are being rediscovered. But I guess it's always good when it comes back again. Neurosymbolic I also talked about. But I think in the end, what we want to achieve is that we want, of course, these systems to be working on our behalf. So we want this system, in the end, the important part is that we want this system to actually create value for us, the humans. So I think this will be the overarching key challenge. How do we both get the competence, the kind of capabilities that we want, but also in a way that we can actually trust the systems and that they provide value for us? Because in the end, I don't think there is any question that it's not a question about either AI or humans. It's all about how AIs and humans together can solve complex and important problems that we are facing. Thank you very much.
We have some time for a few questions, if there are questions here. Let me start. Okay. So I think one thing you didn't mention, but I think was very interesting in your recent work, was that you participated in the AI safety report, right, as the Swedish member. Maybe you could say a few words about that report, and what do you think that led to?
Yes, exactly. So yeah, Joshua Bengio has been leading this international scientific committee on developing this AI safety report. And I was what's called senior advisor, I think they call it, and that was more that we helped reviewing the report and to make sure that it was made sense. So I've been reviewing some of the chapters in that report. But basically the whole purpose of that report is to give where are we when it comes to the research behind this kind of AI-related risks. So for a number of different areas, summarizing what do we know, what is the kind of scientific evidence, and what are the recommendations that we make based on this. So I think this is a very important work to really kind of gather all the research that has been done. So now it's collected in one place. I think one challenge is that, of course, this shows what people have been studying, but there's a lot of things that have not been studied. So sometimes I've got the feeling that maybe it gives a bit of an unbalanced view in the sense that since it summarizes what we know and not what we don't know, I think a lot of things we take for granted, but there has not been studies, and if there's not a study, you cannot claim it, and therefore I think a lot of things that probably would be reasonable to include could not be included for that case. But that's just a minor thing. But I think this could be a very good stepping stone to have a more nuanced discussions on how to deal with this kind of risks going forward.
Thank you. Questions?
Thank you very much, Professor. My question is about the private incentives to build up the consortium you described here. You mentioned Wallenberg Foundation. I saw the SEAP. I'm not sure if the company or another foundation. What's the amount of the private incentives comparing the public budget to build up this whole consortium you described with so many Sweden universities, yeah? Uppsala, England, and Umeå.
So yeah, that's a good question. So when it comes to the WASP program, this Wallenberg AI Autonomous Systems and Software program, that's mostly funded by this private foundation. So I would say roughly about 500 out of the 600 million is probably from the private foundation. Then there's co-funding from the universities and also co-funding from companies. But the majority of the investment there is done by this private foundation, yes.
Really? Yeah.
Yes. But then, I mean, it depends on different programs and different initiatives depending on who provides the funding. But this Wallenberg Foundation is actually the second largest research funding agency in Sweden after the government. So they basically give out, I think, about actually $1 billion every year in research grants in all fields. So it's a really large research funding organization, but it's with private funding.
Other questions?
Yeah. So thank you. You talked a little bit about explainability as it being an important point towards trustworthy LLM. Now that's a topic that interests me because I know that in non-generative AI, like having explainable AI is quite challenging, right? How are we doing with generative AI? Like, what approaches are people taking? Is it working? Is it working better than non-generative AI?
So I think here, I mean, the challenge with explainable AI is how do you evaluate it? So, because I mean, generating, you can ask the language model to explain how it came to the conclusion, and it will generate an explanation. And the problem is, of course, how do you verify whether it's correct or not? And what is a correct explanation? We humans are absolutely terrible at generating explanations. We're very good at making stories, and these stories usually kind of make some kind of sense, but it's probably not, at least not a causal representation of how things actually occurred. So I would say that for many of these, in some sense, it might even be easier for the generative AI because you can just generate explanation just as another form of output, but still the challenge is is that true? Yeah, exactly. But I think there's also interesting work in kind of tracing. I mean, what are the parts of the input that was exciting, generating the output? So this kind of more interpretability. So personally, I find this more interesting to talk about interpretability. There's also this mechanistic interpretability, trying to explain why the models do what they do, and so on. So I think there are a number of different research directions which are all exploring this. But I think in the end, what I think is important is how do we interpret the output so we know how to base decisions on the answer. That is probably what we want, and then explanation is just one way we use to kind of convince ourselves that whatever being stated is correct or possible. Thank you.
Any other questions? Maybe a final question?
So you mentioned that you had worked on ontologies.
Yes.
Do you see any role for ontologies in this setting? So maybe together with LLMs. So for example, you could also train your LLM on ontologies, so similar to code. Or you could use the ontologies to try to find out a really stupid thing that is produced, so showing inconsistencies. So do you see any role here for ontologies?
So I mean, I think one way we have seen this language models use is basically to use, produce formal specifications from the text, and then you can use the formal specification into more formal reasoning tools. So of course there you could then, it would be very interesting, can you generate formal representation relative to an ontology, and then using the ontology to basically steer what output is being produced. I also think it's interesting to see, could one use it to increase the actual factualness? So I mean, there are these neurosymbolic approaches where you basically in the loss function can add logical conditions, and then you basically, the more you violate the logical conditions, the more penalty you get, and then you try to, in the training process, make it more logically consistent. You could imagine integrating that kind of ontological, basically verification, or what you say, check, maybe I should say, that the output is in accordance with the ontology, otherwise you get a penalty. And then you could, in the training process, align it with the ontology, maybe. So I think definitely there should be ways of combining it. I cannot say that I've seen any particular studies on how it can be done, but try to generate some directions maybe that one look into.
All right, so I think there are many other questions I could have, but I think we're up time. So let's thank the speaker again. Thank you.